Hey guys, welcome back. I know it's been a while since I've made a lesson, and I apologize. It's been a little crazy in my house, and anyway, we're all going through this new experience together, and sometimes things are harder than on other days, right? But anyway, here we are today. So you guys have an assignment that is due, and it looks kind of like this one. And if you haven't handed it in yet, I thought that maybe you could use some help. So here are some tips to help you get through this assignment. Okay, so at the top there's a chart, and in previous years I actually did the chart with the class, so I've left my writing on here for you. So we're comparing and contrasting partial and direct variation. So when you have a table of values, direct variation will start at 0, 0, or will imply that it would start at 0, 0. And you can see that in the graph as well. My mouse isn't working today, so you're just going to have to take my word for where we are. Whereas partial variation will always have the x value be 0, and then the y value will be a number. And you can also see that on the graph where the line does not start at 0, 0. Okay, there's some keywords that you're dealing with, partial variation. And then we have our two equations. And you can see that the two equations are almost identical. Y equals rate times x plus an initial value. Now in direct variation, the initial value is 0. So we don't really need to write plus 0. And so that's why you'll often see that there is no plus anything. We don't write the plus down because plus 0 is pointless. However, if you consider it being plus 0, then you can see that the two equations are identical. Okay, so if you're still not sure between direct and partial, look back at lesson 6.3 where it goes through one scenario of each, or send me a message and I can try to help you out with that a little more. Okay. So just bear with me here a moment because my mouse is not working properly. Oh, look at that. Lovely, lovely. Come back up here. There we go. Okay, so we're going to assume that we're going to move on. So here we are dealing with a pizza scenario. Okay, a plain pizza with tomato sauce and cheese is $9. And you can see that represented in the table of values. Okay. So you're first asked to calculate the first differences, and your first difference is the change in your y values, that second column, the cost in the pizza. What are the costs going up by? Okay, now I've added a little note to notice that the x values, the toppings, are increasing by 2 each time. Okay, so at some point in this scenario, you need to account for that. You do not necessarily need to account for it in question 1, but at some point that needs to be discussed, that it's going up by 2 and what impact that has on the cost per topping. Okay, question 2 says describe any trends in the data. So when we're talking about trends, we want to use just words, not numbers, and we want it to be very simple language, like how you would describe the scenario to someone outside of a math class. So often we use the template of as x increases, what is happening to y? So in this case, think to yourself, what is x? Is x the toppings or is it the cost, the total cost? So then you would say as blank increases, so does the other thing, or maybe the other thing decreases or whatever. So you're just kind of talking about what's happening. You do not need to use any numbers here. Okay, 2B, I'm going to leave you to that one on your own. Okay, if you're not sure, look back on some previous notes or send me a message. Question 3, is the scenario direct or partial? Again, I'm going to leave you to that one on your own. The little box here with the little box with the dashed lines is just saying that when you go to a pizza place, you can't order like one slice with toppings different than a different slice when you're getting a whole pizza, right? You have, and so this pizza place, we're assuming you can only order whole toppings, okay? So no decimal, so you can't have 2.5 toppings or half a pizza with this, okay? It's a whole pizza kind of deal. And so that's why the line on the graph as you can see, it's increasing, but it's dashed to show that you either have to order 1 topping or 2 toppings or 3 toppings or 4 toppings. Okay, you have to order whole numbers. Okay. Nope, that's not what I want to do. This is really hard without a mouse. Nope. Okay, let's see if this will work over here. There we go. Okay, so question 4. This is where things start to get really tricky, but this is where I'm really looking to see if you're going to be okay in grade 10 applied math. Okay, question 4 and 5 and 6 are really important when you get to grade 10. So it's really, really important that you try your best on these questions or you ask for help with this kind of stuff. And I will be assessing you on these things again because they are so important for grade 10. Okay, so pick any 2 points, okay, and label them, and then use your equation of rise divided by run to figure out the rate of change. Now, whenever I'm doing rate of change, I always strongly recommend that you turn it into a word rate. What is your rise measuring? And if we look at our graph, going up and down, the rise is measuring the total cost for the pizza. And the run going across the bottom is measuring the number of toppings. So my rise is measuring money and my run is measuring number of toppings. So when I start a word rate, then when I'm filling in my numbers, my y2 minus y1 divided by x2 minus x1, I can try to make sure that the top numbers are all money numbers and the bottom numbers are all pizza topping numbers. Okay, and when I get my final answer, it should represent a money per topping. Now I'll give you a hint, these numbers are a little outdated and lower than you would probably find at most pizza places right now. Maybe if you were just ordering a small pizza, these would be the prices. So they are going to feel a little bit low, but still somewhat logical. Okay, so just check and make sure that you're getting an answer that seems somewhat logical, a little on the low end, but okay, sure, I'll pay that for a topping. Okay, question 5. What do the first differences and the rate of change represent in this scenario? So this is kind of that question, if you haven't already talked about how the table of values increased by 2, this is kind for the toppings going up by 2, this is a good place where you could kind of talk about what that implies. And when we mean for this scenario, you're going to want to be very specific about the pizza, the cost, the toppings, that kind of stuff, okay? Okay, and the last section here is making the equation. Now, this is the toughest part, and in all the times I've taught this course, this is where most students struggle, okay? This is really tough part. So if you're feeling lost, just stick with it. If you can, do some extra textbook practice, ask questions, ask for help, and just practice, 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 okay? So you take your template equation, y equals rate times x plus initial value. Okay, and what we want to do is we want to switch y for something that is represented in this scenario specifically. So if we look up at the scenario, y is our second column in our table of values, and it's the up and down on the graph. So so that means, actually, let me see if I can write this on here. That'd be great. Y, perfect, and here's our y's, right? Okay. So, where was I going? Oh yeah, so instead of y, we want to pick a letter that this represents. And here we have cost. So I said, well, C would be a good letter to pick. So instead of y, you can see that I have put the letter C there instead, okay? And then instead of x, you need to pick a letter that represents x in this scenario. So if we look up at x, it's talking about the number of toppings. So I've picked a T, maybe you would pick an N. Try to pick a letter that kind of matches what you're talking about, okay? And then our rate, we can go up to question 4 to get, and our initial value, we can look up above to get some ideas of what our initial value might be, and we can substitute that in and have our very own equation, okay? So when you're making an equation, there should always be 2 letters that are your input and your output, and 2 numbers that are very specific to the scenario. So if we look back at some work from the other day. Here we go. Here's one on the dog that needs some medicine. Whoop. Okay, and when we made an equation, there we go. Our input is the mass, how heavy is the dog? And so if you input how heavy the dog is, you multiply that by 8 milligrams for every kilogram the dog is, plus the initial 15 milligrams of medicine, then it'll tell you how much pentothal medicine you would need. So if we look down here at some scenarios, we have that if the dog is 2.5 kilograms, so we substitute that in, okay, then we can figure, we input the 2.5 and we get an output of pentothal would be 35 milligrams would be needed. Now I did not write therefore sentences here. I should have, but at least I put the units there, right? So pentothal equals 35 milligrams, okay? So make sure that you either write a therefore statement or you put your units on so it's very obvious what the final answer is. Okay, so give that a try. Now the last question on your assignment, just gonna try and get back to our assignment page here. Okay, so the last question on your assignment, oh yes, we'll give you a decimal. The $10, that will give you a decimal answer, and I want you to use your reasoning and your logic and just answer the question plain and simply. How many toppings can you actually afford to buy with that $10? Okay, so I hope that helps you guys get through your assignment, and I'm looking forward to seeing the rest of those trickle in soon. Take care, guys. Bye. Bye.